So moving on to the last topics. So we have your improper integrals and then your multiple integrals. So these are both definite integrals, but for improper integrals, your limits of integration will be infinite, meaning infinity. So it could be negative infinity going to positive infinity, or 0 to infinity, negative infinity to 0, so on and so forth. And also we also have discontinuous limits. So for example, um, this particular limit will cut off your graph, or it's only up until that point. So some examples of this one are ellipse, hyperbola. So those are some examples of the graph, or any curve with higher degrees. So I think those also produces improper integrals. So discontinuous limits. Now on the other hand, for multiple integrals, so I think this is pretty simple, because what you need to understand here is coming from your differential calculus. So I think you have the topic of partial derivative. So for example, you have, let's say this one, partial of derivative of the function of y with respect to x and then with respect to z. So meaning you are partially deriving variables one at a time. So for example, you derive it with respect to x first, and then afterwards you derive with respect to z, so on and so forth. So that's the idea here in multiple integrals. So in multiple integrals, so instead of deriving or getting the differentiation, so you'll be getting the different integrals for each function. So for example, it is in this order. So you start off with the inner integral and then you go outer. So it's the same as partial derivative. So you may call it also as partial integration, but in topic wise, it is called multiple integrals. All right, so let's start with improper integrals first. So again, we have two types of improper integrals. So first is you have infinite limit of integration, so meaning you have infinite limits. And then the other one is you have infinite discontinuity for your limits. So we'll go to that later and differentiate what is the two types of improper integrals that we have. So first is we have the infinite integration limits for improper integrals. So we have three properties. So let's say in the first interval from a to infinity. So notice that a is a closed bracket, so meaning your lower limit is fixed. So it may be any number on the lower limit. Now, infinity is an open limit because we don't know what particular number is your infinite limit is. So that's why it's an open bracket, or it's a parenthesis. So if ever you have an infinite limit, so what you need to do is you will take the infinite limit outside the integral equation, and then you're going to use your knowledge in your differential calculus and put the limit of the upper limit as the upper limit approaches infinity. So instead of having a infinity limit in your function, so it will be dealt later after the integration process is done. So you focus first on this portion here, meaning you take the integral of the function manually, and then you apply the limits from a to b, and then after getting the limits or applying the limits, second fundamental theorem of calculus, so you then apply the limit of b approaches infinity. So that's what's going to happen in the items that you're going to solve later. So next is if you have a lower limit of infinity, so that's negative infinity. So notice again that the lower limit is an open bracket, then the upper limit is fixed. So again, we take out the negative infinity outside the integral equation, thus creating the limit of the lower limit, which is a, as a approaches negative infinity, and then the integral of the function of x from a to b. So again, you're going to deal with this equation first. Then after determining the definite integral, so you're going to apply the limit of a approaches negative infinity. Alright, so we also have negative infinity going to infinity. So we can split this one into two parts. So let's say your c is the middle portion. It could be 0 because, of course, 0 would make sense because from negative infinity, then the middle portion of your negative infinity going to infinity is 0, diba? But again, it could be any number. It could be 1. Depende sa yung trip. So since you have two functions here, so you may use the first and second properties as mentioned earlier. So this one. So this one is the applying the second property, then this one is the first property. Now the final answer for your improper integral will give us two types of answer. So for example, the limit exists for the improper integral, meaning the value of your improper integral is definite, or let's say it's finite. So meaning it is converging or it converges. Convergent, converging, converges. So those are the terms if your improper integral has a finite value or it exists. So meaning it has any value aside from negative infinity or this one. So otherwise, if the limit does not exist, so meaning it diverges or it is divergent or it is diverging. All right, so you have two types of answers. So that would be converging, diverging. So those are some of the references that you may find in the internet. So converging, diverging, convergent, divergent, or converges and then diverges. So if the limit exists, it converges. If the limit does not exist, meaning it's infinity, so that is diverging, diverges. All right, so questions so far? All right, so let's proceed to the next. So let's try to solve an example. So never mind the graph. So you may not graph the equation, but this is just for um, visualization lang for the example. So notice that this one is an improper integral looking at the limit. So the upper limit is infinity. So again, according to the properties I mentioned earlier, so we need to take out the infinite limit outside the integral equation. So this becomes the limit. So again, since the upper limit is b, so b approaches positive infinity. And then this one is from 1 to b, and then this becomes dx over x, right? Now, at this point, since you replace the upper limit uh, with a variable, so you cannot directly use the calculator. So you're going to manually integrate this up until the final answer. So the limit of b approaches infinity. So the integral of dx over x is just ln of x, and then that will be from 1 to b. All right, and then applying the limit of integration, applying the the limits using second fundamental theorem of calculus. So this becomes the limit of b approaches infinity. So you always apply the limit in the unknown parameter. So this is ln of b minus ln of 1. So if you try to use your calculator, ln of 1 is equal to 0. So what is left in the equation is just the limit of b approaches infinity and then ln of b. So how are you going to evaluate ln of infinity? So I think in your differential calculus, so you're going to try to plug in a very large number for ln. So let's say ln 9999999. So notice as you plug in bigger items, so going to get bigger, di ba? So meaning the answer is infinity. All right. So again, if you try to plug in, let's say ln 99, so the value for this one is 4.60. So let's say if you put 4 nines now, so the value would be 9.21. So if you put another large number, 99999, so 6 nines, so that will be 13.82. So notice that the values are increasing. And again, since our limit of b is approaching infinity, so it is never ending. So meaning the number will get even bigger, diba? So that's why the answer is infinity. And since this one is infinity, so this one is diverging. It diverges. So that's for number 1. All right, so questions? So dali ra siya, no, kay you already know how to evaluate definite integrals. So I think the new thing here is the infinite limits. So this will be the solution. So this 0 part here is ln1. Okay, so let's go to number 2. So we still have the upper limit as the infinite limit. So taking out the infinite limit first, so this becomes the limit of b as b approaches infinity. Then this becomes from 0 to b e to the power of negative x dx. So getting the integral of negative e to the power of negative x, so this becomes negative e to the power of negative x And then the limit of integration will be from 0 to b. So why is it negative e raised to negative x for the integral? So again, take note that the format is eu du. So let u be negative x. So du is equal to negative dx. Then you have negative du equals dx. That's why we have a negative symbol here. So applying the limits, so we have the limit of b as b approaches infinity. So that will be negative e raised to negative b, and then minus negative e. So instead of putting so many minus signs, so we can just put plus here, plus e raised to 0. So e raised to 0, or any number raised to the power of 0, is equal to 1. So this becomes the limit of b approaches infinity, then minus negative e raised to negative b plus 1. So if we try to plug in a very large number, so let's start with negative e raised to negative 99. So don't forget the negative sign for the exponent. So the answer for this one is minus 1.011 times 10 to the power of 43. So this is already a very small number. Diba? So if you plug in another value, so negative, negative. So negative, so that's, and then if you plug in another value of 9, so notice that e raised to the negative 9, negative e raised to negative 999 is already 0. So meaning this portion here becomes 0. So you cannot go any further because, of course, if you try to plug in 4 nines in your equation, so it will still give you 0. So the final answer is 1. And since the limit exists, it is 1. So meaning it is converging. So that's how you evaluate the improper limit. All right, so questions? So this is the solution. So it is equal to 1. So going to the third example. So upper limit is still the improper limit. We're going to have the limit. So taking the infinite limit outside again. So we're going to have 1 to b, and then 1 minus x, e raised to negative x dx. So if the equation is now difficult, so you're going to have to be creative in determining the integrals. So you need to go back to your techniques of integration. So for example, since these are two terms, so one is algebraic, one is exponential, so you're going to use integration by parts. So I hope you can still remember how to use integration by parts. So you let u the easier term, and then dv be the complicated term, but it can be integrated. So complicated term here is negative e x dx. Then the simple term is 1 minus x. So getting the derivative, du is equal to negative dx. So this becomes negative du is equal to dx. And then getting the integral, so this becomes v is equal to negative e raised to negative x. So getting the integral now, so limit of b as b approaches infinity, and then we have from 1 to b, not from 1 to b, but we apply already the formula for integration by parts, and that will be uv minus the integral of v du. So this is uv, which is 1 minus x times negative e raised to negative x, and then minus the integral of v du, that is negative e raised to negative x, and then negative dx. So daghang negative. So simplifying this one further is we're going to have the limit of b as b approaches infinity, and then this becomes 1 minus x negative e raised to x. So minus minus minus, 3 minus signs, it is still minus, then e raised to negative x dx. So integrating further, so this now becomes the limit of b approaches infinity, then 1 minus x negative e rather, to the power of negative x. So this is minus, then the integral of e raised to negative x dx, that is negative e raised to negative x for the integral. So expanding the terms inside the equation, so meaning distributing this one to each term, then distributing the negative sign also. So this gives you negative e raised to negative x, and then plus, so this is plus, so times x, so that would be x e raised to negative x, and then this one is plus e raised to negative x. So notice that we have two similar terms, one is negative, one is positive, so this will cancel each other out. So what is left in the equation is now the limit of b approaches infinity, then x e raised to negative x, and then applying the limits of integration, so that will be from 1 to b. So we also have to put here the limits of integration, so I forgot. So applying now the limits, so this will be the limit of b approaches infinity. So plug in b, and then e raised to negative b, and then minus, so that will be e raised to negative 1. So in other terms, this can be expressed also in this format by bringing down the exponent. And in the denominator, since you have a negative exponent, so you may bring that down in the denominator. So this is b all over e raised to b minus 1 all over e. So applying the limits, so again, e raised to a very big number. So notice that so let's try to put it on the left side. So if I try to put e raised to 99, so let me check okay my question. What the question there? Answer there. So e raised to 99, so that is already a very large number. So that is 9 to the power of times 10 to the power of 42. Diba? And then if you try to plug in e raised to triple nines, so it will give you math error because the calculator cannot handle anymore the big value. So what does this gives us on the left side? So b all over infinity all over e raised to infinity minus 1 over e. So what do you think is the answer for this one? Medyo libog siya, no? So, so with this item, so if you notice that the limit of b approaches infinity, so in the numerator, so let's go back to the lower right portion. This is infinity, and then on the right portion, this is also infinity, di ba? So how do we deal with this one? Is try to remember what you have learned from your differential calculus. If you have infinity over infinity as your limit, meaning that will be the answer of your limit of, let's say, b approaches infinity. So I think there's a particular topic in your differential calculus. So if the limit is 0 or if the limit is infinity over infinity, so you need to use L'Hopital's rule. So if you have forgotten how to use L'Hopital's rule, so just try to remember what the rule is for L'Hopital's rule. As long as, again, if you have improper integrals, I mean sana siya pagtawag sa 0 over 0, and then basta try remembering L'Hopital's rule, and then the limit of b approaches infinity, b over e raised to b will give you 0. So I think in L'Hopital's rule is that you're going to I think if I can remember correctly, if x approaches infinity, and then f of x over g of x will, let's say, give you 0 over 0 or infinity over infinity. So you're going to use L'Hopital's rule, and then you're going to use this formula. So you're going to get the derivative of the numerator and get the derivative of the denominator. So this becomes the limit of x approaches infinity. So the numerator is f of x prime and then g of x prime. So what happens in our example is this now becomes the limit. So using L'Hopital's rule, so the limit of b approaches infinity. So the numerator now becomes 1. Derivative of b is 1. Derivative of e raised to b is still e to the power of b. So applying the limits now. So 1 over infinity is equal to 0. So this is 0 minus 1 over e. So the answer is 1 over e. That will be negative 1 over e. And again, since I think this is converging because you have the value of e is constant. So just try to review L'Hopital's rule. So I think if you have conditions for your limits giving you 0 over 0 or infinity over infinity, or let's say negative infinity over negative infinity, you're going to use L'Hopital's rule. So the answer is correct earlier for sending by Kamai. So it's 0, but the explanation why it's 0 is you have to go through L'Hopital's rule. Because if you're not going to go through L'Hopital's rule, so probably your answer for the limit, since it's infinity over infinity, is 1, diba? Okay, since they are the same values. Alright, so questions for that particular example? Alright, so let's proceed with the next. So this is the solution. So this is just a shortcut solution coming from the reference I got the sample from. So the integration by parts looks like a shortcut method. And then this is the evaluated definite integral. Then again, you're going to use L'Hopital's rule because again, this portion here, if you try to evaluate it first, it's going to give you infinity over infinity. So I forgot the term for the limit of this one. For 0 over 0, infinity over infinity, I forgot. I think it's improper. I forgot the correct term. Just try to look it online sa mga references for L'Hopital's rule. So this is the answer. All right, so let's say you have two different types of limits, infinite limits. So you're going to take out both. So again, as per the property earlier, so you're going to split this one into two portions. So the best way for this one, for you to apply this one is the middle term will be 0. So I think the midpoint between the upper and the lower and upper limits is 0. So this becomes negative infinity going towards 0. And then e raised to x over 1 plus e raised to 2x plus then 0 to infinity. That will be e raised to x 1 plus e raised to 2x. Alright? So taking the lower limit and upper limit outside the equation, So the first equation is the limit of a approaches negative infinity, and that will be a going to 0, e raised to x 1 plus e raised to 2x dx. Then plus the second equation, taking out the upper limit, limit of b approaches infinity, and then that will be from 0 to b, e raised to x all over 1 plus e raised to 2x dx. So since both equations are the same, so you may separately integrate the equation. So let's try to, so the integral of e raised to x all over 1 plus e raised to 2x dx. So notice that this format is, I think it's the same as the arctangent, inverse arctangent format. So du all over a squared plus u squared. Alright, so a squared is equal to 1. So getting the square root, so a is still 1. So u squared is equal to e raised to 2x. So the u parameter is e raised to x. And then getting the derivative, du is equal to e raised to x dx. So notice that every term is replaced. So this gives us 1 over a arctangent u over a plus c, diba? So the final answer for this one is arctangent of u over a. So again, since a is 1, so this gives us directly e raised to sorry. So e raised to x. So going back to the original equation, so this gives us now the limit of a approaches infinity. So the first one is arctangent e raised to x, and then this will be from a to 0. So negative infinity, and then plus the limit of b approaches positive infinity, and then arctangent e raised to x, then from 0 to b. So evaluating the limits, so arctangent 1, so this is arctangent e raised to 0 minus the limit of a approaches negative infinity, and then arctangent e raised to the power of a. So this is the first equation, and then plus the limit of b approaches infinity, arctangent e raised to b, and then minus arctangent e raised to 0. So if you try to plug in arctangent e raised to 0, so again e raised to 0 is 1. So if you try to put arctangent 1, so this gives you 45. So murag bati kay siya tanawon, di ba? So I think it's not appropriate for you to put 45. So try to change your mode into radian mode for you to be able to get it in radians. So if in radians, so this will give you pi over 4. then this will give you negative pi over 4. So for the limit of a approaches negative infinity, so again, e raised to a very large negative number, so this will give you 0. This will give you 0. So pi over 4 minus 0, and then plus, so e raised to a very large positive number. So let's say e raised to 9999. So if daghan na kay 9, so murag mo error siya, di ba? So I think up until 2 nines only. So this will give you a very large number, 9.89 raised to the power of times 10 raised to the power of 42. So this will give you infinity. So taking the brackets off, so let me put it on the left side because there's no space. So pi over 4 minus 0 plus infinity minus pi over 4. So pi over 4 is cancelled out, pi over 4 is cancelled out, 0 is also taken out of the equation. So what is left is infinity. And this is diverging because the limit does not exist. So marag sayop, no? Sige, question. Zero, 4. If you try to plug it in your calculator for a very large number, so if you try to plug in e raised to negative 99999, so that will give you 0. So muna 0 siya. So I think I'm wrong there. So since we are using radian mode, so since we used radian mode here and also radian mode here, so you need to use radian mode as well for arctangent e raised to a very large number. So let's try. So e raised to the, let's say e raised to 99, and then arctangent of the answer. So it will give you kuande. So this is wrong. So let me correct it first. So again, if I'm going to, so if I'm going to plug in e raised to 99, so this will give me 9.89 times 10 to the power of 42. Then I'm going to plug in arctangent of 9.89 times 10 to the power of 42. So again, take note that this should be in radian mode. So this will give you pi over 2. So this is pi over 2. And the answer is pi over 2. So this one converges there. So this is the answer. All right, so questions or clarifications? Okay, so I think you can understand this one easily, Rigid. Okay, so let's go to the next topic. So since one of my questions, so let's try to go to the next topic, which is the infinite discontinuities for improper integrals. Okay, so for infinite discontinuities, so I think what you can found siya pag, I think on how you understand this in a simple manner is that if you try to plug in b directly in your given equation, or let's say any limit, if you try to apply it in your equation, given equation, so if the resulting answer is not undefined or it's not zero, so meaning it is continuous. So if it's zero or it's undefined, so meaning the limit is discontinuous. It is only until there ang inyong limits. So that's why it's open. So let's say b is discontinuous. So it's open, b is open, but it's open up until the left portion only. So b is not included in the limits. So it may be, let's say the value for this one is 8. So 8 is not included, but less than 8 is included in the equation. So same goes for the second term here. So that's why if you try to observe if the discontinuous limit is taken out in the integral equation, so notice that the limit of c approaches b minus. So this b minus here indicates that all the range from that particular number on the left side of it is included in the limit, excluding b. So that's why it's b minus, because let's say this is your number line, this is point p. So this one is going negative, diba? This one is going positive. So meaning all the terms or all the numbers on the left side of b will be included in the evaluation of the limit. So marag-ana siya nga pag-evaluate. So let's say if you try to evaluate the limit later, so instead of 8, you're going to plug in 7.99. Ano, diba? So it's still the left of 8, but it's not equal to 8, because if you're going to plug in 8, it will give you a zero answer or a undefined answer. So muna siya pag, I think, on how you can understand this one on a better perspective. So for example, if the lower limit is now discontinuous, so notice that a is an open interval and then b is a closed interval, so meaning it's closed, but b is also included in the answer. So if a is discontinuous, so we take a outside the equation, we take it as a limit, but the limit of a later on, what is included later on in the limit is just the right side of a. So let's say this one is 0. So if you try to evaluate the limit later, so what you will plug in your equation later is, let's say, 0.11111, diba? Basta as long as it's not equal to 0 upon the evaluation of the limit. Okay, so you also have the third one, the same concept as the third property earlier. So if the two intervals are discontinuous, so you need to split it into two parts and then apply the first and the second properties of your improper integral. So this one is the first one, this one is the second. So still the same for infinite improper integrals, infinite limits. So you still have to have two types of answer. So one is converging, one is diverging. Alright, so let's try to evaluate now your improper integrals. So again, how can you spot that your given equation is improper. So, di ba, at first glance, we can just say that this is just a normal definite integral. So, you can just plug this one in your calculator. Right? So, if you try to plug this one in your calculator, so let's see if this will give you an answer. So, from 0 to 1. So, notice that if you try to plug this one in your calculator, so this gives you a math error. So that's one way of determining if the given integral is improper with infinite discontinuity. Diba? I think it's difficult to spot because the given limits are all real numbers. So compared earlier, you are given infinite limits, so you can say that it's already improper because you are given the infinite limits. So another method is if you try to plug in either limits in the given equation. So if I try to plug in 0, so this gives me 1 over the cube root of 0, which gives me an undefined number. So with a lower limit, I can already say that my my given equation is already an improper integral, with the lower limit being the discontinuous limit. So if I try to, so this one is discontinuous. So kung asa siya mo 0 or kung asa siya mo undefined, so that is your discontinuous limit. So 1 over the cube root of 1. So this is 1. So this one is continuous, or it is finite. So meaning I'm going to take 0 out first. So I'm going to take this one out because this one is discontinuous. Because again, it's discontinuous because upon plugging the value in the equation, so this gives me an undefined value. The upper limit gives me a finite value, which is 1. So taking the lower limit out, so meaning the lower limit is discontinuous. So A approaches Baliday. So this is C rather. C approaches A on the right hand side of A, because again, we don't want to be dealing with 0. So greater than 0 is included, but 0 is not included. That's why it's A plus. A on the right side of A. Then the limit of A to 1 dx all over the cube root of x. So getting the integral, so let's try to evaluate the integral. So this gives us x to the power of negative 1/3 dx. And then this gives us the limit of c approaches the right hand side of A. So it's not blood type, but you're going to think that it's blood type B minus A plus. So this gives you n plus 1. So 1/3, negative 1/3 plus 1, that will be x to the power of 2/3 all over 2/3, and then the limit of A to 1. So this gives us the limit of C approaches the right hand side of A, and then you're going to have 3x raised to 2/3 all over 2, and then the limit is from A to 1. So taking the limits now, so this gives us 3 and then 1 to the power of 2/3 all over 2, and then minus the limit of C approaches the right hand side of A, Then that will be 3a raised to 2/3 all over 2. So let me just correct the other terms here. So marag redundant na kayang a. So this is 0 day, 0 plus the right hand side of 0. So if you're going to plug in a very small number for this term here, so let's say 0.0001, so it's still the right hand side of 0. So 0.0001 raised to the power of 2/3. So it will give you a small number, which is, let's say this is approximately 3.16 times 10 to the power of -8. So it's almost 0 na, diba? So if you try to plug in a very large number na pod, a very small number, so 0.000001 raised to the power of 2/3. So let's say pila na siya ka 0. So let's say you're going to plug in 8 zeros. So it gets even smaller. So it's now 3.16 times 10 to the power of -14. So if you plug in a very small number, as long as it's not 0, it's the right hand side of 0. So it is just equal to 0. So 0 times 3/2. So this will give you 0. So this is 3/2 minus 0. So the answer is 3/2. And this is converging. This is 0 plus the right hand side of 0. So did you get it, or confused mo on how to apply the discontinuous limit? So okay, so so just try to review what I said na lang, and then just try to follow what I did in the example. So this is the solution. So again, let's say you're going to plug in 0.000. Let's say you're going to plug in 10 zeros raised to the power of thirds. So this is still valid because this is on the right hand side of 0, 0 plus. So point and then 10 zeros raised to the power of 3/2. So this is approximately 3.16 times 10 to the power of -17. So in decimal form, that's 0.00001234123412334. That will be the value, right? Then multiply it by 2/3, by 3/2. So it gets even smaller. So that's just approximately equal to 0. So that's why you can take this one out. Then what is left is 3/2. So in graphing aspect, if you try to graph the equation, so it won't be touching x equals 0. So this will, let's say it will serve as a asymptote for your x equals 0. So this will go into infinity, but it will never touch 0. All right. So let's go to another example. So again, if you try to plug this one in your calculator, so that will be 1 over x cubed, and then from 0 to 2. So again, the resulting answer for this one is math error if you're going to use your calculator. So you know that this one is an improper integral, but you don't know where the limit is discontinuous. So plug in the lower limit, plug in the upper limit in the equation to know if both are finite. I mean in discontinuous limits. So 1 over 0 cube. So this gives you 1 over 0. This gives you undefined. So it is discontinuous at the lower limit. So 1 all over 2 cube. So this gives you 1 over 8. So this is defined limit. So the lower limit is undefined. So that is the discontinuous portion. So taking the lower limit outside the equation, so this gives us the limit of C approaches, that will be A day. C ba to? A day A. A approaches 0 plus. So meaning the right hand side of A only. Because of, so it's not A minus, it's not 0 minus because we are on the lower limit. So we are going towards the 2 limit. So that's why it's 0 plus the right hand limits of 0. So this gives us a to 2 and then dx over x cubed. So getting the integral, so by getting this one to the numerator, so this gives us a to 2 x to the power of negative 3 dx. So this gives us the value of, so x minus 2 all over minus 2. So from a to 2. So this gives us the limit of a approaches the right hand side of 0. Then you have negative 1 over 2x squared. Then that will be from a to 2. So giving the limits, so this will be negative 1 all over 2 times 2 squared. This will be the upper limit. Minus the lower limit. This gives us 1. Correct, huh? So this is the limit of a approaches the right hand side of 0, and then negative 1 all over 2 x to the power of a. So again, x raised to the power of, let's say, 0, 0, 0, 0, 1. So this already gives you a value of 0, diba? Sakto? Bali de, bali sakto, sakto. So this is so excuse. So sakto siya. So sakto to, sakto. So thank you, thank you. So this is a raised to the power of 2 de. So let's try to reverse. So let's say you're going to plug in a very small number, 001 squared, 0.0001 squared. So that will give you a small number. So this is approximately, let's say, 0, 1, 2, 3, 4, 5, 6. So you have 6 zeros. So this is equivalent to 1 times 10 to the power of negative 14. And then if you times 2 it, so it gives you again a very small number. So 1 divided by a small number will give you a very large number. And then it's negative. Diba? Sakto? So this gives you negative infinity. So minus, and then this gives us negative 1 over 8. So negative 1 over 8, and then minus minus, so this gives us plus infinity. So even if you subtract negative 1/8 from infinity, the answer is still infinity, and this is diverging. All right. So that's how you evaluate infinite discontinuities. And this will be the answer. Okay, so for the other item, so let's just skip this part here. So you can try to review the recording later because we still need to discuss the multiple integrals. So this will be the solution. And then the last improper integral. And then this will be the solution. So just try to evaluate this one on your own later. Improper gyapon. This one is converging. So if the limit exists, so this one is converging. So for the other example, so don't have any value for it yet, but try to solve this one on your own. So this one is, for this problem, it is converging. So this is some of the problems. So this is the problem set for improper integrals, but again, I won't be giving any problem sets anymore for that, so that you can review for the final exam. So just try to use these as your review materials. So I already included the answers in the items here. So 10 kabok. Okay, so now let's go to multiple integrals. And this will just be a quick discussion because I'm just going to give you the concept behind the the multiple integrals. Excuse. So for a while. Okay. Sana may equation. So this is what the multiple integral looks like. So you're going to have multiple snakes, di ba? As you can call it, di ba muna siya itong mga integrals. So how do you evaluate this one is you go from inner integral going to the outer integral. And again, the concept of this one is more likely the same as your partial derivatives, but you are just partially integrating. So again, inner going outward. So meaning first is you need to integrate with respect to x first, and then evaluate the limits. This will be the first step. The second step is you need to evaluate the next integral that is with respect to y. So that's super easy. So integrating with respect to x first. So notice that the first term don't have an x. So that will be so let me so from 0 to 6, then place a bracket. That would be 27x, then integrate the next term. So since we have a value of x here, so this becomes x cubed over 3. Then evaluate the next term. So again, just ignore the y portion because we are integrating with respect to x. So this gives us negative 1/2 xy squared. And then evaluate the limits. That will be from 0 to 3. Then dy. So again, take note that you cannot use directly the calculator because you have another variable here. So you need to manually plug in the values of your limits. So from 0 to 6, so this gives us 20, from 0 to 3 rather. So 27 times 3 then minus 3 cubed over 3, and then minus 1/2 3 times y squared, and then minus, so 27 times 0 minus 0 cubed over 3 minus 1/2 times 0 times y squared, and then dy. So try to put as many bracket and braces as you can. So 0, 0, 0. So what's left is the inside term here. So 27 times 3, that will give you 81. So 81 minus 9. So taking 1 3 out. So that will be 3 squared now. And then you're going to have 3 halves y squared. And then this is with respect to y now, dy. So simplifying the equation is you now have 72 minus 3 halves y squared dy. So I think at this point you can use your calculator. Then the answer will be so at that point you can use your calculator because the unknown parameter is only one variable. So the answer is 324. So of course, if the multiple integral gets bigger, so murag sa very last portion mo makagamit sa calculator. And then this is the answer. So again, you may be up until this point only. Then you can use your calculator because you now have one unknown parameter to deal with. So for example, you're going to evaluate 3. So dz first, dy next, and then lastly is dx. So it's not necessarily that you're going to start with x, y, z. So it will depend on the arrangement presented in the problem. So that's the order. So the first integral will give you z. Then that will be from 0 to 5x over 2. Then dy dx. Then applying the limits. So you're going to have 5x over 2. Then the other one is 0, so you can just ignore that one. The next is the y parameter, so this gives us from 0 to 2, and then 5xy over 2, and then from 3x over 2 to 3. So this gives you from 0 to 2, and then you're going to plug in the limits of integration. So 5 times 3y all over 2, and minus 5 times 3x over 2 baliday. So that's wrong there, guys. We are integrating with respect to y. So 5x times 3 over 2, then minus 5x times 3x over 2 all over 2. So cancel out x. Then this is now dx. So from 0 to 2, this gives us 15x over 2, and then minus 15 over 4, and then dx. So at this point, you can use your calculator, and then the answer is ako na-delete ang answer. The answer is 5 siguro. So let's try to find out if it's 7.5. Basta ang answer niya is 5 siya. So just try to look where I got a mistake. So that is the answer. So for your review items for multiple integrals, so these are some of the items that is for the problem set on that, but I'll give it as your review materials. So those are the answers for the different problem sets. So again, I won't be asking the output for this one. This will serve as your review materials.